So welcome once again. This is the lecture number 3 of the Artificial Intelligence course. In this session, we are going to talk about the type of AI agents. So we will continue our discussion that we were having in the last session, and we will try to understand that what are the different kind of agents. So there could be different requirements, and based on this, different kind of agents can be deployed. We would also understand that how we can define an environment of an agent, because you know that depending upon the environment, the agent behavior changes. Some environments are easy, some environments are difficult. So how can we clearly specify that what is the technical way to specify that what is the environment related to a AI agent? Also, we would start our discussion with the discussion that we were having in the last session, that how can we define that what is the goodness of a particular agent, and based on that, definitely many things actually take shape. So with this, welcome once again, and this is the lecture number 3. So I will just try to have a recap, very quick recap, so that just to connect things in this lecture. So what we were doing in the last class, what we understood in the last class is this, that there is something called agent. AI, in the AI domain, we are going to make some agents that have sensors, that have actuators, and by sensor they sense that what is inside the environment, and actuator they do something so that the environment, something happens into the environment, and we want to make in such a way so that it is a rational agent. We have taken an example that where let's assume that we have a vacuum cleaner, and this vacuum cleaner can suck something, suck some dirt. If dirt is there, he can change his location from left to right. And our objective, the objective of this particular agent, is to clean the room. So I'm not going to operate it. He's going to operate in autonomous way so that it can clean all the rooms. So all right. So we have seen that if it is possible that it is possible that he is into the room number A, and room number A is clean. He is room number 8. Since here in our example only 2 rooms, I'm going to say that let's assume only 2 rooms A and B are there. So he is into the A room. This room could be dirty. He is into the room B, and this room could be clean. B room could be dirty. The 4th thing can happen with him. Okay, these are the 4 things which are possible for him at a particular moment. So if from this environment, if we try to achieve that what is the current status based using the sensors, he would be able to see the percept out of at least one of them is actually there. So he can take the decision based on this. If something is happening, it is clean, what decision he have to take? It is dirty, then what decision he have to take? So implementation, actually, we have seen in the last class that actually it is better to make a table where for every possible thing, I'm going to tell that what action he should take. So for example, when the room is clean, he should go to right hand side. When B is clean, then he should go to the left hand side. And when there is a dirty, he should suck. Here also he should suck. So something we can say like that. So this is one way, and another way could be that instead of because sometimes what happens that it is not a simple and this is such a simple setting. So it may be possible that he was traveling many rooms where he was traveling something. So sometimes you also want to see that what he had done into the previous times. Okay. And this is current what he had done into the previous time, and based on this, what is the current situation? So let's assume that this is the current percept, and whatever has been happened, also he can take those things also into the consideration to take what action I'm going to take the next. Okay, so by this you can think that this is a starting of the way in which actually we are going to have the memory. So if we want to have, for example, memory size is k, let's assume that the memory size is k. So at one place, how many values are possible? In this particular setting, we have seen that 4 values are possible. If let's assume that n number of values are possible. So, and he is going to consider the the value to be k size history he is going to consider. So how many different string can be made? K multiplied by n, because am I right? I think n to the power k. Okay, am I right? Because at every place k values could be there. So 2 to the power, I think 2 to the power k 10 to the power, because in every location I can put the k values and these n values, sorry, n values. And here also I can put n values. Here also I can put n values, and these values could be anything. So how many values are possible? I think here n to the power k values are possible. And if I want to make a table, so definitely what you have to do, you have to make this table in such a way so that for every possible configuration which are going to originate from here, I have to tell that what to do. For example, for every configuration, I have to tell that what I have to do. Let me also assume that the values that he can take action. For example, here how many things he can take? He can go left. He can go left, he can go right, he can suck, or he can do no operation. 4 operations. Let's assume that he can do these 4 operations. It depends upon the capacity of the agent, that how many actions he can take. So if 4 actions he can take, so you have to tell out of these 4 things something over here. Am I right? Am I right? 4 things out of 4, 1 thing is going to be there. So again, this everywhere I have to tell that what to do. So here, for example, I say that go left, go right, some operation, no operation, something I am going to tell like that. So what is the size of this particular vector where I am going to specify that what action I have to do? What is size of this thing? So definitely the number of values, whatever the number of possible values were there, for every value I'm going to tell something. So the size is going to be of this n to the power k. In this particular example, this is going to be n to the power k. Yes or not? Okay. So at every place I have to say something. These n to the power k places, everywhere I have to again assign something. And these values are 4 values. So total size becomes 4 to the power n to the power k. You see that how exponentially this, first of all, is it clear? What is the size of this particular table? How many entries I should have? Because for all possible values, I have to tell that what action I have to take. So these many number of things are at least required so that I can fully explain the things. Yes or no?
So n is the number of percepts, sir?
Okay, so right now I'm telling that, yeah, number of different states into the percept. By percept, how many different things are coming? Okay, right now we have fixed.
And then k is what?
Yeah, k is the number, is the history size. How many values, previous values, I am going to consider to take the action. Okay.
Thank you, sir.
So, there could be various ways to tell this thing, and based on this mathematical formulation may differ. But right now in this formulation, you know that these many things out of all these cases, for all of these cases, I have to tell that what action I have to take. So definitely my table size must be at these many number of items. For each item, I have to specify that what action I'm going to take. So therefore, the size of this particular vector which actually specifies that size of this particular vector, which actually specifies 1 minute. Size of this particular vector, which actually specifies the actions to be taken by this, is going to be what? This. And at every place I can put how many values? At every place I can put how many values? For example, in this particular case, 4 values I can put. So total number of possibilities which I can put. For example, everywhere I can put go left, go left, go left, go left, go left, go left, go right, go right, go right, go right, go right. No operation, no operation, no operation. So all these things are possible. So how many possibilities are there? For every place, four things are possible. So total number of things are actually 4 to the power n to the power k, because n to the power k was here. So this we have seen in the last class, that what is the size of this. Then definitely what we have actually come to conclusion is this, that lot of functions are there. So definitely those functions all those functions are not good. So how many functions we have just now talked about in our current setting? How many functions we have talked about? And 4 to the power, what was this? N to the power k. Oh my god, this is going to be very big number, even if for the small n and k. So let's assume that by this dash I represent these functions, okay, these different functions. So they are so many. So so whether all of them are actually intelligent, whether all of them are intelligent? No, because I have just told you that everywhere, if I write this is an exhaustive list, na? So what would happen that if I say that go left, go left, go left, go left, if I just put left, 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 this is not a good agent because it's not cleaning anything. If I say suck, 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 again it is not a agent. It is sitting in one room and only sucking. Go right, 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 right. Okay. So all those things would also be here. So they are useless kind of agents. Okay. So, but however, since every possibility is there, there will be someone who is going to be very good. Yes or no? He is going to behave because nothing more than this I can do. Okay. This is the thing because in every situation you have to decide that what to do, and if somebody is going to tell you that what to do, then nothing more than this you can do. Do you agree with me? Yes or no? Do you agree? Nobody is telling. Yes. Hello.
Yes, sir.
Yeah.
Yes, sir.
So nothing more than this I can do because in all the positions, if somebody in all the please explain 4 raised to the power and raised to the power k. So okay, I will come back to this once again. So right now, try to understand this particular part. Lot of functions are there. Okay, and many of them are useless. Yes or no? Just type yes. Many of them are useless. They are not intelligent, but definitely if whatever intelligence is possible, because whatever kind of network agent is there, there will be one function. So there would be one very good function. I'm not sure there. Based on whatever requirement, there would be one function looks like that. This is very good. Everybody, there would be. Let's assume that one best function. So I can say that one best function. Yes or no? Everybody, please type yes or no.
Yes,
There will
sir.
be one best function. So where are other people? Just type Y in chat so that you can also accustom to write something. Everybody, can you write yes? 2, 3, 4, 5, 6, 7. Very good. 8, 9, 10. Right now. Yeah. So you agree that there would be one function which is actually the best function. So there are in this kind of formulation, there are two problems. One problem is this, that best function means what? Can you define for me? What do you mean by best function? So you cannot tell any function as a best function, okay? Until you have some measure. For example, if there is a race, I want to tell somebody that who is the winner. So I cannot tell anybody that you are a winner. Okay, we have to find out that what is the time he has taken to complete the 100 meter sprint. So then, based on the values, I can say that somebody has taken, for example, 9.6 seconds. Somebody has taken 10.8 seconds. So somebody take 11.5 seconds. All these things are larger number. Then I say that okay, since he has taken the lesser amount of time, then he is the good. He is the best person. So to define this thing, we have to come up with some number. And this number we can come up using what? Some kind of measure, performance measure. And what is this performance measure? What is the performance measure? Right now, that time taken, in this particular example, the time taken. So somehow we have to define that what is the performance measure. And objective of the agent is to, because agent want to be good agent. So he definitely would not like to be this particular kind of dumb he don't want to use this particular function. He don't want to use this particular function. So a good agent would try to use this particular function. Everybody is okay with this? Yes. A good agent would try to use this particular function because I have told you that this is the best function. But to define the best, we have to somehow find out some quantification. And to find out this quantification, we have to take the help of some performance measure. What is the performance? For example, in the race, performance measure is the time. Okay, inverse of the time, 1 upon time. For example, you can say that 1 upon time. So performance measure. Okay, so there should be a performance measure that can define this best one. Second thing that I wanted to discuss with you, will there be only one function which is actually the best one?
No, there can be many other functions also, depending upon the performance measure, I guess.
No, you're correct. Yes, exactly. So that's why when I have written this one, you should say that no, sir, there is a problem. It could be more than one. So, however, when I say the best, so for example, because number of functions are very large. So what would happen? For example, here 9.6 is the minimum. So many of them had the 9.6. Many of them are 9.6. If somebody has 9.4, then definitely he is the best. Only one is there. But now in terms of the when this number is very large, so it is most probable that whatever the best number I have, it may not be one. It would be more than one. Okay, and sometimes it is also possible that even if it is not very intelligent, it is fine that unless some intolerance limit, if I can define that, okay, in this tolerance limit, for example, in the examination, I want to pick a few people, so I can say that anybody who get 5% less number than the maximum person is also allowed to give this particular examination. Is qualified for the interview. So it happens many of the time. So with the maximum, sometime also I can apply some kind of tolerance. So very interesting thing is this, that there could be more than one functions which are actually good, and our objective is to pick them. How to pick them, we'll talk about later. But right now, I just wanted to tell that if you do a brute force approach, so will this be a good idea? Brute force means testing one by one each of them, that how good they are. Means testing means what? Taking loading this particular profile on the on the agent and then determining that what is the performance measure. This is not going to be a good idea. So there should be some intelligent way so that from this I can do something and I can reach to this particular best one. So I can navigate in this particular thing. How to navigate well is actually a very interesting area. And generally, whenever we say machine learning, so generally this is what we mean, that how to navigate in an effective way into this particular domain so that we can find out the solution. Many solutions, but how to find out the good one is a actually important point. So make sense? All right, so let us come back to this discussion that what is the performance measure once again. Let us come back to this particular thing, that what is the performance measure. So how can I define the performance measure? How can I define the performance measure? An example. So we have seen that in terms of the racing agent, the time was, I was telling that 1 upon time taken to complete the 100 meters string. This is what it is. That I say that this is the performance measure. So I think we have touched this point this particular point in the last class also, that there are two things we can think about. That whether agent is good or whether effect of agent on environment is good. We have to consider this particular part. Whether this agent is very good or his effect on the environment is very good. Good agent have the good impact on the environment, may not be. And whatever I'm telling right now, it's a very philosophical thing. You can sit down and try to, when you are having a cup of tea at that time, if you try to understand this particular part, you would be very much, what I say, that you'd be it would be eye-opening kind of thing. That most of the time, our focus is on this particular agent, that how good this particular agent is. However, performance measure should not be on the goodness of this particular agent. Instead, what is its effect on environment? We should put this as a performance measure. I think I have given example in the last class that let's assume that he is a person in the world. This is our Earth. Okay, so and he is a person. I want to find out that how good this particular person is. I want to make a good agent. You want to be good in your life. Somebody want to be good in his life. So how can I measure that how good this particular person is? This was the basic question that we have actually addressed in the last class. That how can we tell that what is the goodness of this particular person? Let's assume that there is a, in a word, I want to find out that how good this particular person is. So we can define that, okay, agent is good if he have a lot of money. Okay, agent is good if he have a house, good house. He have a car, or so many things we can define. Okay. So in the last class, I think I mentioned that if you define the things like this, then what this agent would do in the world, because he want to get the money, so he would go to bank and just rob the bank. Can anybody earn money more than the robbing? For example, somebody is robbing the bank, and he has in a 1 hour time he is able to get 50 lakhs rupees. Can he do anything else to earn this money? Means in terms of the performance, if I consider this as a performance measure, then he's the best person, because nobody else has this particular, nobody else can earn the money in such a short time, this much amount of money in this much short amount of time. Similarly, for the house, I also told you that he can do something bad thing, that he tell that everybody go out from the room and I would be here, something like that. But that is also a bad thing. In terms of the individual performance, this particular agent is actually very good, because I think I should also tell in the complete way. So I was telling that he can do all sorts of bad things to earn house, to earn car, because stealing a car is again something that he buy within 1 minute. He would be able to get a car. Somebody was there, he had parked his car, he just picked that car and went away. So within 1 minute he would be able to get the car. Within 1 minute, within 1 hour he can get something, some money, some house, everything. So in terms of the individual performance, this particular agent is very good, because he have actually performed the thing. But when I see the effect on the environment, it's very bad. This is very important. That performance measure should be not on the agent, and it should be based on the not of agent. It should be not based on the agent. However, what is in our hand? Only change the agent. But by changing the environment, we have to see that what is the effect on the state of the environment. Any questions on this?
No, sir.
Yeah. So performance measures should be designed according to what actually we want into the environment, not what based on the agent. However, sometimes this is not very straightforward to define. That what is, it is not easy to define. Why? Because let's assume that we want to design something for the world. So what should be the person's life? How the person's life should be? Because we are going to define the performance measure in such a way so that everybody is living simple life, or some ups and downs in the life, what you want. Sometimes the person may have lot of money, sometimes person is less money, something happens in his life. For example, if somebody is a businessman, sometimes he have lot of profit, sometimes he have very less profit. So whether this kind of thing is better or simple life is better? Can you tell me which is better?
It depends on the individual, sir. Some people,
Depends. Okay. And there could be many situations also. For example, if your mom comes to you and tells that take the breakfast and I have two things, apple and banana, what would you like to eat? Okay. Doesn't make any sense. Which is good. Anything is fine. Okay. Sometimes there is no notion of goodness. Whatever you take is fine. Okay. So there are scenarios when the performance measure does not give you the any value higher or lesser. So ultimately you cannot tell that which agent is better or bad. So these things are very important. Okay. Everyone in moderate poverty or someone rich and some poor, again the same similar kind of behavior. So again, very difficult to design because what should be there if it is not straightforward. So the performance measure actually is very important and it defines the criteria for the success, that how good this particular agent is with respect to the environment. Agent prior knowledge into the environment is actually can help you to set the things better, because if agent has some prior knowledge, he can start from some of the good places from where he can reach to the goal early. Okay. So I think there is a very interesting paper that actually talks about that what is the last landscape. So this paper actually talks about that whenever you want to optimize something, generally the space is not something like this. So generally in the optimization problem, now generally what we do, we just put this kind of curve and say that if you are here, you go into the negative direction of the gradient and you would be able to reach to the minima or maximum, whatever you want to do. So all these things are possible. Okay, but in the real life, the scenario is not like this. Scenario is something like this. This, something like this. So even if you are here, you would be stuck at this particular point. You'll not be able to reach. So what I wanted to tell, for example, if this is the scenario. So if you are here, you would be stuck to this particular point. You'll not be able to reach to the global minimum. But if you have some prior knowledge, agent has some prior knowledge, so he may start at this particular place, and then by this he can search something and he can reach to this particular place. Okay. Rationality also depends. Rationality means taking right decision also depends upon the actions that the agent can perform. Because if he is restricted not to take some of the actions, and how can he take that particular point? Okay, so okay. Agent percept sequence till date. Again, this is also important, that history, how much history he is allowed to take. So based on the history, he takes the things. Okay. So all these things are important. So rationality, how good this particular agent is dependent upon what the things, how much he have prior knowledge, what are the different action he is allowed to perform, how much memory he have to take, and what is the performance measure. So rationality depends upon all these factors. All right. So what we have discussed, that for each possible percept sequence means the history, whatever he has. The rational agent should select an action. Agent is going to take the action. Which action? Now, first time I'm going to talk about this. Till now, what we have seen, that in the table, whatever values are there, right now we have not discussed about this, that let's say we have only said that it could be a random value. Yes. But yes or no? Have we talked anything about this, that how can we find out the good value? First time we are going to talk about this, that this value, what action he should take, should be such that is expected to maximize the performance measure. That is expected to maximize the performance measure. So now a Bayesian approach you can take. Find out which particular thing is going to have the larger probability of maximizing this particular thing. Because right now we don't know. What do I mean by don't know? So what happens now, as in the environment, agent is actually doing something, and environment can also change. So right now, what decision he is taking may be proven at later point of time that this decision was wrong. You remember that when the last class discussed that from A to B, if you were going, there was one path of 10 minutes, another path for 20 minutes, and you took 10 minutes path. And but what happened that when you are traveling at that time, there was some rain happens, and you are stuck in this particular place. It takes 30 minutes to reach over that particular place. So when you reach here at that time, I can tell that you are wrong. You took 30 minutes. Why have you not taken this 20-minute path? This was a highway. There was no problem. No such problem could be there. So at that time, at the end, it may be possible that you can tell that things are actually not good. But at the time when the person was deciding, it was a correct decision. So this is what they expected. This is what we say they expected value that I am going to maximize it. Because here I'm expecting that 10 or 20, and to maximize the performance, I'm going to take this particular path. In the reality, this is going to be wrong. So I want to maximize the expected one. Given the evidence provided by the percept sequences, because he is definitely taking that, seeing that what is sensing into the environment. Okay, and whatever the built-in knowledge the agent has. Built-in knowledge again is an important word here, because it may be possible that initially he have only few values available, but as the system evolves, it gets more information, and by this it becomes better and better. Hope it is clear to you. Any questions on this? Yes or no? Do you have any questions? No questions? Okay. So let us discuss one thing. I'm going to give you a performance measure, and this performance measure is I'm going to give you a performance measure for this vacuum cleaner agent. And how can I measure the performance? This one. Award 1 point for clean sequence at each time stamp. Okay, clean square at each time stamp means what? That how you are going to make it. So I'm going to make a table where I say that time. What is the time right now? What is the time right now? And what is the time right now? And time is 1, time is 2, time is 3, time is 4, time is 5, time is 6, like that. And award. If both the A and B both are clean, then I say to give 2 marks. If one of them is dirty, I give 1 mark. If both of them are dirty, I give 0 mark. And in the same way, I give a mark. Is it a right performance measure? By this, if the vacuum cleaner want to maximize this cumulative award, will this be a good idea? Will this be a good idea? Krish, Atul. Based on time, game theory, yes. Nobody is speaking. Can you speak? Will this be a good idea? I'm just asking random names, okay? Gaurav Chopra, Harish, Kollu, Soumya.
Yes, sir. That seems to be a good idea because we are actually trying to measure the performance based on the environment. So,
But for this, at one instance of time, the amount the amount has been reduced. It should be directly proportional or it should be increment according to my expenses.
Okay, so actually this is the award at this particular moment. So there would be summation also, that how much initially it becomes 2, then 3, then 0, then 4, something like this. You want to say this? 6, 8. So this is what the award I'm going to give right now, and definitely there will be a summation also. At the end, he whatever value he gets, that he wanted to maximize cumulative value. Make sense?
Yes, sir.
Yes.
Yeah. Okay, so this is a good thing, because this is we want. Okay, as you rightly mentioned, that this is we want in the environment. We want the clean squares. So the number of clean squares, based on the number of clean squares, if I give every minute I see that how many squares are clean, I give him marks. So he would try to do something so that he get the maximum number, means all the squares are clean. He want to do like this. So this is a good performance measure. Okay. So
Professor, just one question. Sorry.
Yes.
One question is, but if we go with this approach, it means that we have to run through 4 to the power k to the power n, right? Like for all that number of times, we have to look out for each and every agent, right? To understand.
No. Let me just once again clear this particular part. So what I was in the previous slides, we were discussing that how many functions are possible. Okay. So that was some n to the power 4 to the power n to the power k. Okay. So how many functions are possible? But agent would be only executing one of them. I would load this configuration on the agent, and then the agent would be working on that.
Okay.
Make sense? So I want to find out which one is the best one. Okay, I think where is that particular slide? I want to find out which one is the out of these available ones, which one is the actually best one. I would, based on the performance measure, I would be finding out that this particular configuration is such that gives you the maximum marks. Okay, based on this particular performance measure, this particular configuration is going to give you the maximum marks. So I want to load this particular configuration to the agent. Multiple configuration also.
But to understand that, I have to run through for all the configurations, right?
Correct. So okay. So this is the second thing, that how to find out the best one.
Okay.
To find out this particular one, which actually perform this kind of good behavior, which has this kind of behavior. Your question is how to find out this. Okay. I think now I understood your question, that out of these 4 to the power n to the power k, which one is better? How to find out that thing? Yes or no?
Correct. Yeah.
So right now we are not touching this particular point. We'll come back to this later. There are various ways into the automatic learning, and this is actually our important. This is going to be one of the important part of our course, that out of this overwhelming number of possibilities, how to find out the best one in an efficient way. Otherwise, you cannot find out this. So how to find out? Let's just keep that thing. So let's assume that we have some method to find out best one. Okay. So we would find out the best one which does this particular kind of thing, and then definitely that would be a good agent. Fine. If we pick that particular agent which performs according to this particular method, it would be a rational agent. Yes or no? That would be a rational agent. Okay. Now I'm going to tell you another performance measure. This performance measure says award 1 point for clean square at each time stamp, same thing, and put penalty for movement to left to right. Okay. So now what is going to happen, that if when he at any point of time, I would see that how many squares are clean, and I would give the marks based on that based on that. And apart from this, I'm going to also have something called penalty that says that have you moved from here to here? Have you moved left or right to do this particular part, this particular operation? If you have done this, then I would put -1 over there. Okay. I would put -2 marks, -1 marks. Okay. So if I say that I can put anything, na? Let's assume that -3 marks I award if he is moving from one place to another. Once again, if both the rooms are clean, he get 2 marks. One room is clean, he get 1 marks. No room is clean, he gets 0 marks. But if he changes the room, there is a penalty for the room change. If I say that penalty is -3 marks, what would happen? Can you assume? Can you understand what would happen now? And why I am going to give the penalty? Why I am going to get the penalty? Why I am giving the penalty? Because you know that if he changes from one room to another, he have to spend some energy. So I want to save the energy. Okay, it may be costly to go from one room to another. So if I put -3 at the end, what is going to happen? Is he going to clean that all the rooms? So here, what is the objective? That apart from the cleaning, I also want to save the money. Am I right or not? I also want to save the energy. Yes. So what happened by applying this particular thing? What happened? Can you find out that what happens if I go by this, whether cleaning would be there or not? Whether cleaning would be there? Yes or no?
Yes, sir.
No cleaning would be there because if he goes to the second room, if he is inside this particular room, and if he goes to this room, he have to give -3 rupees. Even there, if he cleans something, he get only 2 rupees. So that is a wrong strategy. This is actually the wrong strategy. If I put -1, maybe sometime he can go there and want to clean this. If I minus 0.5, there could be something. So you can see that if I put the penalty in that particular term, so then this particular method becomes non-rational because now I don't want the environment in this way, na? That there should be some dirty rooms. But because of this thing, sometime he have to decide that whether I have to go into next room or not, and that is a bad thing. Okay. So everybody understand that this particular strategy is not rational. Yes or no? Yes or no?
Yes, sir.
Okay. So let me give you one more thing. Let me ask one more thing from you. Let's assume that I give one more strategy, and this strategy is this that let me just cut this. This strategy is such that let's assume that in this at the time when he sucks the dirt from here, I also put some sensor that finds out how much dirt is sucked. Okay, let me change first this particular part that now there is one more sensor that tells that how much dirt he has actually sucked, and I am going to put this as a performance measure that amount of dirt sucked. Money is equal to reward is equal to amount of dirt sucked. Reward is equal to amount of dirt sucked. If I put this thing, is it a good assumption?
No, sir, because in some cases they might be a dirt or more dirt, or they may not be a dirt. So in this case, you can't say that these rewards will be applicable in this case.
Okay. Good.
It is, yes.
Any more observations?
Yes, sir, because we are trying to measure performance on the amount of that.
Bala, I cannot hear you.
Am I audible,
output
sir?
performance. We
Yes,
can
yes.
remember.
Yes, yes. Yes.
So it improves the performance because we are rewarding on the amount of dirt sucked.
Okay. So you are telling this is a good thing.
Yeah.
This is a better way, huh? If I do like this, then it would be a rational agent.
Yeah.
Yes.
Yes.
Any other observation? Anybody else?
Professor, in my opinion, it is more about the performance of agent itself. It may not have a direct impact on the environment. So it may, like, from that, it may not be a good performance either.
Why you are telling? Because if he gets more money by sucking the things, so whenever there would be even a small amount of dirt, he would try to pick that.
It will try to pick that, but then it might be a room where the dirt is little less. Okay, and then another room, the dirt is high.
Okay.
But I mean, the agent would be getting less reward when the dirt is low, even though the room has been completely cleaned.
So what he
So
would do,
that's
because in the next by your logic, he can go into the room where that dirt is high and suck it, get more reward. But after that, there is no dirt, so he would come back in the previous room and clean it. Because in the same room, he is not getting any reward, so he would come to another room and get the reward.
yeah, but then in both the cases, the impact on the environment is same, right? Why will I give a more number to the I mean, at the end of the day, the room is getting cleaned, right? So the impact is same on the environment. How does it matter that the dirt is more or less? Correct?
Look, so what you are telling that essentially by having this strategy also the room would be cleaned. Am I right?
Yeah.
Am I understanding the same thing? So
Yes,
if the
yes,
room is clean, then my task is done. It means that it is a rational agent who is cleaning the room. I am achieving the same thing which I wanted to achieve.
Yeah, yes, we will. I mean,
Okay.
from the point.
So it is
also,
so it is a rational agent. Yeah. Again, it is a rational agent because what I wanted the clean rooms, and the rooms are clean.
Sir, here in which way we can say that the rooms are clean, because we are analyzing the performance of this particular machine based on the amount of the dust which it has taken. So on
No.
the room may have more.
Sorry. I am not measuring that how good the cleaning is based on the how much dirt I have. I am telling how much clean this room is. This is the separate method to find out whether both the rooms are clean or not. If both the rooms are clean, I get 2 marks. If one room is clean, I get 1 marks. Otherwise, 0 marks. It was the earlier thing. Right now, what I'm telling that I'm not giving the marks like this. Come and show me that how much dirt you have collected. I would give you reward based on that. Okay, I have changed my strategy. And are you able to understand? I have changed this particular strategy.
Yeah, okay.
Point is, by this strategy, also the room are getting cleaned, and I would be also into the same position which this particular thing was giving. Yes or no?
Yes, sir. Okay, understand.
Huh?
So
Yes.
Professor, you mean like by this strategy, at the end of the day, the machine will clean the room, right?
Yes.
So this will be a rational agent.
Yes.
That's what you are telling, right?
No. I just wanted to discuss this thing. Okay. Right now I'm telling this, but I wanted to discuss with you whether I'm telling right or wrong.
Yeah,
I wanted to discuss with you. So do you all agree that yes, professor is telling correct?
Okay, Professor, I've got a view here.
on this situation. So the agent will look around. He or she, I mean, that agent, it will basically move around, trying to look for dirt. Okay. And even if it's a smaller amount of dirt, it will clean it. Basically, uh, it will clean it, but the energy may be more used by the movement and also by frequent cleaning. So since we are discussing, I think based on the information, we are thinking that my thing is that maybe this will consume more energy.
Yes, correct. I agree with that. This will consume more energy, but right now energy is not our factor right now. In this particular setting, right now energy is not factor. And I also my focus is only to see that whether this agent will be rational or not.
Yes, it will.
Will everybody? Is there anyone who is not satisfied?
Sir, one another view is what happens if the dirt is not there? Right?
What happens if dirt is not there? Yes, okay, correct,
so
correct.
If the dirt is not there, then it keeps on cleaning it. There is no point. So we have to find first whether the dirt is there and to what extent. Okay, and then only probably take a decision to clean it or not, or the other other person who just said the more energy is spent unnecessarily there without the dirt, without the amount of dirt which is already there. So
I
that
think
is also one more point. Yeah.
I think your point is actually is very valid. That we have to find out that is some way that if there is no dirt, why to unnecessary search for this thing. So for that there should be something, some mechanism, and then by this it would be a different function, altogether different function. So we would come back to that later. So this is the more requirement. But right now in this particular scenario only, do you have any issue? Question. Is it a rational agent? Can you type yes or no?
Yes, sir. It is rational.
Everybody. Somebody has written no. Yes. Yes. No. 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 Amit Kumar is telling no. It is not a rational agent. Why? So let me define in this way. Rationality means what? That whatever I wanted to achieve should be achieved into the environment sense. Okay, rationality means into the environment. What I want into the environment, it should be clean. So looks like that if I say that reward is equal to, if I say that reward is equal to amount of dirt sucked, if I give this as a reward, then looks like that it is going to clean the room, and by cleaning the room, my task is done. It is a rationalism. So this is my logic. However, so everybody okay with that?
Yes, sir.
However,
one viewpoint, right? Reward should also be based on the room cleaned, right? Even though the room may have a very less dirt, still the room is getting cleaned, right? So there has to be some minimum rewards that has to be given based on the room itself.
So
even though there is a less dirt.
No. So right now we are not discussing that what kind of reward should be there. Why I'm not discussing? Because here I have discussed earlier that this is the way to give the reward. Okay, I'm giving you a different function. I just wanted to discuss this particular function. Just tell me about this function. Whether if this particular function is there, if I say this, you can come up with many ways. No? If I give this particular function, whether it would be a good function or not, it would achieve the cleanness into the environment or not. This is my question. Yes.
It will actually, it is one of the criterias.
Yeah, it will. Okay, everybody is okay. Let me tell you that why I'm asking, stretching this question, because this has some very serious issue. This particular thing has. because I wanted an amount of dirt sucked. Okay. So if and in my sensor is, what is the sensor that I have in at the point of sucking, there is some sensor applied which can tell that how much dirt it has sucked. After sucking the dirt, if this agent dumps the dirt into another room, okay, and then go to that particular room and sucks, cleans that room, and whatever he has cleaned again puts into the another room and start cleaning there. Can you see this? Hello. Can you see this?
Yes, sir.
Yeah.
So this particular reward looks very good, but it has serious problem. The serious problem is that it because of the problem formulation, it gives it scope to play a game where from dirt collected from one room he can put into the another room, and then again he can clean that particular room and put it here and start cleaning in this particular way. So your environment, in your environment, every time both the rooms are actually bad, but the performance of this agent is very good because he's sucking lot of dirt. So again, that's why I was touching on this. Can you find what is the problem over there? So apart from the direct things, there could be a possibility of indirect thing also. So I think a story is coming in my mind. I'm not sure about with the complete detail, but you may have also heard about that. In some country, there were a lot of mouse. So the government announced that if somebody kills a rat and he gives to the government, they would be giving 100 rupees. So what happens? What happened? Everybody started breeding the rat. So by this, the rat population actually, instead of decreasing, it increased. So this is very important. Okay, when you define the performance measure, it's very important to see all these factors also. All right. So rationality is not perfection. We know that rationality is not perfection because everything is not known to us. Rationality maximizes the expected performance only, and not the actual performance. This is we should always keep into mind. Okay, so different kind of when we have different kind of agents. Let me talk about some of the scenarios which are actually very prevalent. So if you want to make the things very correct, what is required? It is required that somehow you know everything. Omniscient means he have all the information about the scenarios, and then he can take the decision. Is it possible to have the omniscient? Isn't he have all the information to the environment? Okay, so generally it is impossible. So if your agent is made in such a way that it can take the decision if all the information is available, then this agent will not be able to function because all the information is not there. I think I missed one point. Somebody has written that agent becomes corrupt agent. Okay, somebody has written that agent becomes corrupt agent. Okay, so let me tell you this thing that there is no corrupt agent. Okay, your word is such that he want to maximize his own performance, and that's why we cannot tell it is wrong. There is no word corrupt. Okay, it is fine. Corrupt means what? Corrupt only happens if whatever is told to him, he is not going to do that. Agent is going to do the same thing, but he is doing something by which it is increasing its performance. Now corrupt, you cannot tell because agent is correct. Okay, agent is doing correct thing. Now your rules are such that now he would definitely try to exploit the rules, and by exploiting rules is not corruption. Okay, try to understand. So your method should be foolproof. Okay, if somebody makes a loophole and somebody utilizes that, then you cannot tell that he is bad. Actually, he is good because this is his requirement. For example, I'm not My statement can be taken wrong also, but in the, I don't know, but in the, if in the income tax, somebody pays less income tax because of some of the rules, so he's not bad, he's correct, because if there was some rule I can take the advantage of this, why should not I take the advantage? Even if he's not taking the advantage, then he is doing the wrong thing. Okay, so you cannot call it correct. All right. What I wanted to tell here, one more thing, that information gathering is an important part. Information gathering means exploration. So whenever in the environment your agent is working, so whenever it moves from one place to another, he is exposed to more information, and then by this he should update its table also and its working environment, its behavior also. We have talked about a lot about this. The initial configuration is very important. If initial configuration actually also provides you some kind of data, and by this it can improve its performance. Okay. So if there is an autonomous agent, means agent is actually discovering on its own, so it can compensate for the partial or the incorrect information as it goes by. Sometime it may be possible, for example, if there is some natural calamity and there is some agent that is going to help the people who are stuck into the environment. So you don't know that what is the environment. So when the agent goes inside, it keeps creating the how the environment looks like here, how the environment looks like here, and therefore when he navigate, he get more and more information. He arguments and incorrect and the partial knowledge that he had, he actually increases the knowledge, and by this it becomes better and better. This is a very interesting line that I wanted to tell, that task environment is a problem which a rational agent have to solve. So if we go to the problem formulation, we can say that task environment is a problem that is given to the agent, and this agent is going to solve this particular thing. At the end, he wanted to do something. So what, for example, in the natural calamity scenario, people are stuck over there. So initially, this is the problem given to him, that save all the peoples. What is the end state? What is the solve state? That nobody is inside the danger zone, and he does something for that. So task environment plays a very important role, because as I told you earlier also, that some same agent can be performing differently into the different environment. So how can you define the environment? So the question comes that how can you define the task environment? If you have, because if you want to develop something, you have to set up the rule for the game. So how can you define the task environment? So there are actually 4 things. That first you define that what is the performance measure. What is the environment? How can you define? What are the different actuators and what are the different sensors? Because using actuator means what? How much power you have. Using sensor means how much information you can gather. Environment, if it is a complex or what kind of environment, and how the performance measure is defined. So task environments is defined using these 4 things, and in short we can say that PEAS, PEAS. So if I ask you that give me the PEAS for this particular problem, so you have to tell that what is the performance measure, what is the environment, what is the actuator, and what is the sensors. So let me take to explain it. Let me take an example, and let me take the autonomous taxi, autonomous driver car. For this, what is the performance measure? Safety, that how safe he is driving, how fast he is driving, how legal he is driving, how comfortable he is driving, how much profit it is going to earn. It's a taxi, so he have to earn some money. So it performance measure may not be all of them, maybe only how safe he is. We wanted to understand. Based on this, I can tell that we can tame it, or sometimes we can use more than 2 such things, and we can have the combination of them. So again, all these things are possible. Sometimes these things could be counter related also. So you can say that safe, if it is fast, then how can it be more safe? Okay. So if we want safe and fast both, so speed should be lower. Okay. If it is more fast, then it is not that much safe. If it is more fast, then it is not legal. If speed is greater than this limit, then it's not legal. However, based on the requirement, we pick some of these things. So what is the performance measure? What is the possible performance measure? You will be defining safe, fast, configurable, whatever you wish, you can define. What is the environment? So in the autonomous taxi, environment is a road. How much traffic is there on the road? Whether what are the location where pedestrians are there? There is a customer sitting inside the car, taxi. So all these things are part of the environment. What are the actuators? How can it change, do something so that environment changes? Steering, accelerator, brake, signal, horn, and display. What are the sensors? So definitely he would be having some camera, sonar, sound waves, speedometer, GPS, odometer, engine sensors, keyboard, etc. So all these things would be your sensors. So for the autonomous taxi, PEA is defined in this particular way. Okay. In the settings when actually we want to go for the software agents, so software agents generally, we also call them soft boats. They have the unlimited kind of information power. So a lot of power they have, because how much cameras you can put. But if it is a memory, you can very easily increase the memory to whatever requirement you have. Some of the examples for the PES is here. Medical diagnosis system. So how can you define the performance measure? How healthy the patient is. How you are reducing the cost of home operation, etc. Environment is a patient, hospital staff. Actuator are display of questions, test, diagnosis, treatment, referrals. What are the sensor? Keyboard entry of the symptoms, finding patient answers, etc. Similarly, satellite image analysis system, part picking robot. There is a robot, when something is going on, he wanted to pick something, right kind of things, or faulty things from the conveyor belt. So what is the percentage of part incorrect into the bin? He wanted to find out. This is a performance measure. So what is the environment? Conveyor belt with parts and bins, arms and hands, which are actuators by which he goes and picks something. What are the sensor? Camera, joint angle sensor, etc. These things are there. Refinery controller. So refinery, you know that purity of the oil, etc. They are important. And interactive English tutor. So similarly, some examples are given over here. You please read them and let me know that if there is any confusion. So for the different kind of agents, if you want to define it completely, you have to define PEAS. Okay. Next thing that I wanted to discuss is task environment properties. So, sir, can you please share end-to-end project of an AI which we can refer academic project? Yeah, definitely we would come to that some point of time. Please wait. Okay. So next thing that I wanted to discuss about this, the task environment properties. So task environment could be fully observable or partially observable. Okay, I think it is clear by its name. So fully observable, can you give me an example of fully observable task environment? Generally games such as, chess. In the game of chess, fully observable. Where are the other things fully observable? An example of partially observable thing, you know that when game of, I think there is some shooting game, etc. Such as PUBG, etc. You don't know that what is inside the next room. So those are the partially observable. So autonomous driving car is also. So let's assume that this is the road. When the car is here, it only sees that what is here into this particular area. Partially observable. Okay. Any questions on this? Fully and partially observable. Yes or no? Single and multi-agent. Single agent means in the environment there is only one agent. He is playing something. Okay. And multi-agent means there are more than one peoples are there. So you know that there are multiple. PUBG, for example, is a multi-agent. Am I right? Single agent could be game of Atari. So there are some balls over there. You are hitting this, and by this it is braking going down, and then there is some something that you take left and right so that it bounces back on that. So game of Atari again is a single agent, and game of PUBG is a multi-agent. And similarly, you also see that game of chess is also multi-agent. Game of soccer is also a multi-agent if it is inside the computer. Also, again, you can think the same way. When it is a multi-agent, they can do a competition, they can do a cooperation, they can do the communication between them. So all these things are possible. Deterministic and stochastic, that's very important thing. Try to understand. Swarm or drones. Okay, yes, swarm or drones. Very good, correct. So deterministic and stochastic. Deterministic means if you want to do something, now this happens. And in the stochastic environment, if you want to do something, you are not sure that it is going to happen or not. Okay, try to understand what I'm telling. It's very important thing I'm telling. Don't take it lightly. Okay, so once again, deterministic means if you do something, it is going to happen. So you know that now. This is what the scenario is. I'm going to take this particular action. After taking this particular action, environment state is going to change, and I would be into this environment state. This is deterministic, but it may be possible that something doesn't happen. For example, I'm not sure that it happens or they're not. I have not good player, but for example, in the PUBG game of PUBG, there is you are firing on some of the things. Okay, it may be possible that your fire may misfire. Have you seen that any kind of game where your fire can misfire? So this is a stochastic environment where you are actually firing, but there is a probability that with the 0.9 probability this gun is going to be fired or not. So those things are stochastic. Are you making sense? Am I making sense? So in some game scenarios, if the game is made in such a way so that agent does those things, but it doesn't happen. Okay. Our word is stochastic. Okay, it's not deterministic. Next thing that I want to discuss is the episodic and sequential. So there is a very simple difference between these two things. It's actually, if you want to do something, you have to do sequential thing. Nah? First this, then this, then this, then this, then this, then this. For example, if I give you an example that there is let's assume that there is a robot, and this is a room where a lot of items are there, A, B, C, D, E, F, G, H items are there, and robot is parked over here. And let's assume that I say that go and find out, pick me the item number D for me. Okay, so what would happen? What is the step? Can you tell me? That first start, it would start, get down from this forward, so that it reach to the gate, open the gate, go pick the D, come back, lock the room, give forward, give me D. Am I making sense? This is how it is going to be done. Yes, can you write yes?
Yes, sir.
Can you write yes? Yes. However, if you analyze, you can think that looks like that start and from here to here reaching to the gate is actually the fixed thing. Whenever I would ask X item, X, Y, Z, any item I ask, he have to perform all these things. Okay. So there could be some scenario where I can say that all these things are going to happen as a sequence. It is an episode. Okay, I can say that episode number 1. Okay, this is the one episode. Then open the door is the episode number 2 because he have to put in inside the lock some code, etc. Whatever, I don't know. So you can define something that this is the second thing. And after that, 1, 2, 3, 4, all this is the third episode. So what is episode? if you can club some of the sequential thing in one that looks like that this is the one is episode, then this is episode, then we get episodal. Otherwise, it is a sequential. So at the lower level, everything is sequential. One by one, you are going to do. In the episodal, what happens? Some action, I have to perform these 5 things. In one action, there are 5 things in one. Make sense? Yes or no? Any questions, confusion? Static and dynamic, everybody knows that. For example, game of chess is a semi-static one because it is static when actually when it is my turn, it is static. Everything is stopped over there. But when I take the thing, then somebody else takes. So at that time, it is moving. Okay, I'm not moving. I'm not doing anything. So other things are moving. So it is a dynamic system. So you know that also autonomous driving car. So when I'm here, when my car is here, so other cars are somewhere. For example, here is one car, here is one car. So they are going somewhere else. But when I reach to this particular place, this car is here, this car is here, this car is here. So something other things are also moving. So it's a dynamic system. Okay. Otherwise, in a static system, things are not changing. So can you give me an example of any static system? So we have discussed about this natural calamity scenario, na? So natural calamity if happened, there is some building which has actually has some issues. So now it has happened. Now it is static. My agent is going inside to discover that if there is something is over there or not. So he have to discover that thing. But things are not changing right now. Okay, whatever is there is there. So you know that is static and dynamic. Any questions? Production line in factories is static. Production line in factories is static. No, because production line is how can this be static? It is a dynamic because things are changing. They are coming from here to here. So when I pick something, another person item is pushed. I think it is a dynamic environment. Next is discrete and continuous. Also, discrete and continuous, everybody knows that, for example, into the game of chess, if I am here, I go here. So in between, there is no motion. Okay. From here, I come here. From here, I go here. In between, things are not there. Okay. So discrete. Continuous, autonomous vehicle. So from here, if I go here, in between points are also there. It's continuous. Okay. Try to understand that this is very, very important. Deterministic and stochastic, many of time people actually get confused. Once again, let me tell you that what is the difference? Difference is this, that here in the stochastic, in the deterministic, if you want to do something, it is going to happen. In the stochastic, there is a probability. With the probability 0.9, it is going to happen, otherwise not. It may be possible that you have taken the action, but action failed. All right. Known and unknown environment. This is again a very important thing that sometimes you know that what is inside the environment, but unknown environment means you are not known about this. So you are placed over here, you see that what is nearby, then you move in this particular thing, you explore this thing. As you move by this, you are going to explore that what is nearby, and you are actually going to do the exploration into that. So different task environment examples are here. Crossword puzzle is a fully observable. You see this single agent, and it is deterministic because whatever is there is not going to change. When whatever is written over there, it is there only. Words are not changing. Sequential, one by one, you are going to put the things. Static, yes, it's not changing. Discrete, and discrete means for one state, it goes to another state. Similarly, there are various 5-6 examples are here. Again, I would not go into that much particular detail. I would call you that please see by yourself and try to understand that it is fine for you. Okay. So I just wanted to give you 20 seconds. Please see this. If you have anything to discuss, let me know. Refinery controller, partially observable because I don't know everything about this. What is boiling inside, I don't know. Outside, I can see that what is over there. Single agent, one system is controlling everything. Stochastic, I don't know that if I'm boiling, it is boil or not. Things can change also. Sequential, one by one, I'm going to apply this, then I'm going to apply this to clean sequential. And dynamic, things are changing, continuous, one state to another state. All these, if I'm raising the temperature, all other temperature is also available. So in this way. Hope it is clear. Okay.
Sir.
Now, yes.
Sir, in the previous slide, known and deterministic, right? Previous to this, there are two definitions. One is for known and one is for deterministic. So what's the difference between these two?
Okay. So known and deterministic and stochastic is completely different. Once again, what I told you, that if you fire a gun, okay, it is going to fire, or it is not, it can misfire also. If every time it fires, I say that it is deterministic. If there is a possibility of misfire, I say that is stochastic. Clear? Stochastic is probabilistic. Okay.
Yes.
Known unknown is this, that I don't know about the environment completely. Here, for example, if you are in natural calamity scenario, some agent is being sent for the rescue. He don't know that what is inside. So whatever he sees, based on this, he develop the map and all other things. Okay. So known environment, for example, chess, known environment. You know that all these things are there. Crossword puzzle, you know that whatever is inside this known. What is unknown? Unknown is when it is autonomous driving car. Autonomous is also known to you. Most of the time you know what is the map, but it may be possible that you are taking the car in such a place where there is no map. If you don't have any map, what you would do? You would keep building the map. So unknown is this, that you don't know about the environment. You are exploring to find out what is the map, what is the things over there. Clear?
Yes, sir. Makes sense.
Thank you. So,
this fully observable and partial observable is also the same thing, right?
No. Look, fully observable, partially. I know that it is known environment to me. It is known environment to me that where I am sitting inside the Pilani. It is known to me. I am sitting inside my room. It is known to me. But who is standing in front of my room? It is not known to me. Who is standing in front of my gate is not known to me. So this environment is changing. Environment changing not in the complete sense. It is changing in terms of the behavior. Some people are coming, going, traffic is changing, something like this. This is what the traffic map is. This is what the map of the city, but I don't know what is the current scenario of the traffic. Okay. So this is what the difference between partially observable. In the partially observable, what happens? That even if you know that everything, but what is happening in front of you, you can only see from in front of you. For example, you also partially observable. Your word is also partially observable. You can only see what is happening in front of you, your eyes. What is happening behind you? Do you know what is behind your back? You don't know. Okay, something could happen. So it is again in the same way in the car. 100%. There are some black spots. You don't know that what is over there. Make sense?
Yeah.
All right.
Yeah. Okay.
All right.
All right. Just one last. Discrete and continuous it is not very clear to me.
Okay. In the discrete, what happens now? You jump from one state to another state. As I given, I think this this example of chess is very fine. For example, if you have a horse, so horse goes 2.5. Okay. So it need not to go from one place. In between, if there are other things are also there, there is no problem in that. Okay, it can go for 2.5. It just jump from one place to another. But if it is a autonomous car, then you cannot go there in that way. It is a continuous. All these in between places should be clear. Then only you can go from one place to another. Okay.
Okay.
Okay. So there is a question that what is episodic and sequential. So sequential means one by one you are going to do something. Okay. Sequential means one by one you are going to do. In the episodic, what happens that few things are allowed as a atomic thing. Okay. Episodic is again a kind of sequential only, but here instead of one thing, multiple things are possible. Multiple things you have to do in one go. Okay. So for example, in the game of Go, I think it happens now. So in the game of Go, you can kill many peoples in a row, if possible. So it's a episodic, because if you're not cutting, then it's fine. But if you get a chance, then you can get multiple things. There is an episode. Episode means one by one by one by one. There are few things are actually fixed. Sequential means only one. Unit is only one. If you are allowed to perform more than one operation in one go, then it's episodic. Make sense? Asutosh?
Yes, sir. Just a little doubt regarding the non-deterministic part. When we say it is episodic, then it means it is non-deterministic, right? Because there are many solutions.
No. Episodic, what I wanted to tell, episode. So if you want to do some operations, okay, if you want to do something, as I told you that there are multiple steps involved to complete the task. Do you understand this part? If you want to do anything, you have to do multiple things. So this is sequential, because one, you cannot replace the steps from here to here. One by one you have to do. I have given the example where I was telling that there was in a room, some items are there. There is a robot. I want to ask him to pick a particular item, for example, ABCD, XYZ, any item I want to pick. So he have to go from here to here. This also involves multiple steps. So either I see this in this way, that take one step forward, go down, something like that. So if every step I look in this way, that every step is independent and one by one things are happening, then it is sequential. But I can say that, okay, go from here to here. It's a sequence. I know that 5 steps you have to take. So if I club some of the things in one, then it is called what? Sequence. Okay, if I club something, it becomes sequence. Then it becomes sequential kind of thing. Correct?
Got it.
Any more questions? So I just wanted to ask you, can we extend this session for 5 minutes? Yes?
Yes.
Okay. So so I wanted to go to this particular slide. That's a very interesting slide. Okay. So if you want to make a agent, okay, how would you make? Again, now you have good understanding that if you want to make a agent, you need to have some architecture. Means there should be some device you have to make. For example, one robot is over there, and in that robot you have to put a program. Okay, so with the architecture you have a program, and both the things make your agent. Now your agent is ready. Okay, so how the agent would work? So one method is to develop a table-driven agent. What is this table-driven? So there is a table. We have talked about this, that there is a table. There is a table. In this table, what is there? That in this situation, what to do? So in this situation, there is a history with percept, we know, and then what is the action is specified over there. Okay, so whenever a percept comes, you see this very easy. Okay, in the table-driven agent, whenever a percept comes, so there is a history. Huh? So append this percept to the percepts. So I have a history. I have already collected history. So I have a history. So whatever new thing come, I am going to put in front of this. So I'm going to append it. Okay. So based on this, I have to take the decision. So I would look up in my table that this is what the percept says, and inside this particular table, I would see that what action I have to take. So by this, I get the action. On this, I would find out that what is the action. This action I'm going to return. That's it. This action I'm going to return. This is how the table-driven agent works. Fine. Very simple, na? I think it is so simplified that even I need not to tell anything. Any questions on that? So this is how the table-driven things work. So now the main topic that today's class was this, I think. So So this kind of table-driven agent is actually generally not possible because of the combinatorics. We know lot of combinations are there. We have seen that this table is going to be very large. So size of table is an issue. Okay. Also, it would not be a nice idea to have table because then it is fixed. Then the things are actually fixed. So what to do? Okay. So generally, we are going to study about 4 different kind of agents. One is called the simple reflex agent. Another is called the model-based agent. Another is called the goal-based agent. And fourth one is called the utility-based agent. So I would just briefly discuss over here. And then in the next class, we would talk about this in the more detail. So there are one we have talked about. Okay. So there is one possibility that you develop a table-driven one. But this is not a good idea because size of table is generally very large. So it becomes difficult to go ahead with that. So we develop different other kind of agents. One agent is called reflex agent. Another agent is called model-based agent. Next is called goal-based agent, and another fourth one is called utility-based agent. Reflex agents are such agents. Please focus. Okay. Very simple thing. Reflex agents actually they work on if this happens, then what? On this kind of rule. They have multiple rules of this particular thing that if this happens, then do this. If this happens, then do this. And you also know that there is something called a reflex action that we perform. For example, if there is some fly coming and trying to strike your eyes is going to blink. Okay. So this is your protection mechanism that we have. Do you think that something is coming over there? What is this size? What is this? And then you blink it. If it is very small, I would not blink. If it is big, then I would blink. Do you think something like that? Never. So these reflex agents are actually like that. For example, if in autonomous car, if the car sees that the car just in front of current car has red backlight on, what does it mean? That he have applied the brake. So immediately he also applies the brake. Otherwise, what would happen? It would be an accident. Okay. So their response time is very less. They are very fast. So this is one kind of agent which is actually called the reflex agent, which has what? Very less memory. If then kind of scenarios, because given something matching this, you can think that that there are a lot of multiplexer kind of circuits that immediately find out that whether this situation happened or not, and then it take it forward. Next thing is called the model based. In the model based, it has a model. So it's things that a word looks like that this or this or this. Word could be of this kind or this kind or this kind or this kind or this kind. There could be 4 different kind of states. For example, when you feel hungry, so what is this particular time? If it is a morning time, then you know that it's a tea time. So you can take the breakfast. If it is a 1:30 or so, you check that no, I want to take the heavy. Same feeling that you want to eat something. Same feeling at the time of 4 p.m. looks like that you want to take the snacks. In the night time, you take the something light dinner. So what is the model? You know that there is some model of the world. In this second kind of agent, it actually maintains that looks like that there is some model of the things. And when there is a model, then I am into this particular state. If something happens, again, there is something if then else kind of thing is also going to happen. Then I would take the action based on this particular model. Otherwise, I would take the action based on this particular model. So if I build the thing into this way, it is a model-based agent. Clear or not? Yes or no? Same thing can have a different response based on the current model that I have here. Model is a kind of misnomer over here. try to understand the model as a state, different kind of states. Yes or no? Clear?
Sir, but reflection model looks to be same, sir, at the moment, not able to exactly.
Yeah, but it has, in the reflex model, there was only one model. You can think that it has only one model. In all the cases, it has the same answer. But here into the model-based one, we have multiple things. So based on my scenario, I'm going to take the decision. So my decision can change.
Sir, his model is like a switch case in case of programming.
Correct. I'm telling now. That's why. I'm telling that it is something like state. So you can think the switch case something like that. You change the case and then you apply the if cases over there.
Okay. Got it.
Next thing is the goal based. That's a very important thing. Okay. Next thing is a goal based. So actually, what happens that why you are taking this action? Because you have to ultimately reach to some situations. So if you want to solve a particular problem, then you must be a goal-based agent only. Because goal-based agent has some target. If this happened, out of various options, I would choose those options, that option which actually takes me to this particular final state. So just think in this way, that system is changing from one state to another. Goal-based agent have some goal. So whenever there is something happens, it takes the decision based in such a way so that it reaches closer to the goal state. So goal is very important. If there is no goal, then the system is actually does not have much sense. Okay. So if goal is also there, then planning comes into the picture. Planning comes into the picture. Search comes into the picture. Search comes into the picture because now I have to find out the thing which are better for me. I would go into more detail into the next class. Right now, I just wanted to give the understanding. Okay. So in the goal based, what is important? That it is more complex, which can actually solve the problem. This is the one which actually can solve your given the problem. Given this problem, what is the solution? So it would do the planning. So based on the things, it actually moves the things in such a way so that it at the end reaches to some goal or final state. Make sense?
Yes, sir.
Make sense? Yeah.
Yeah.
So the fourth one is the utility based. So if you make a goal based agent, again the problem is the same. That few minutes back we have talked about. That my agent want to be good agent. Then where he is going to put the effect on the environment. Okay, it may be very good agent, a very rich person, but may not have the good person. Okay, again you understand this part now. What happens that this agent is very good. It can solve your problem, but the agent is not good because it is not giving the good effect on the environment. So if when we put this thing into the factor in, that what is the utility to our environment? What is how it should be utility good? It should have the good utilization into the environment. Environment people should be happy with that. So if I put the good utility into the picture, then it becomes, then I think the behavior changes. It becomes a perfect one. So utility-based agent also brings the perspective that what is expected into the environment. When I put this thing into the picture, then it becomes a utility agent. So finally, utility agent is the one that actually I wanted to make. But in the process, different kind of things are there. And we will be seeing this into more detail in the next class. Okay. Sorry, I extended, I think, more than 5 more minutes. It's 12:09, but I think it's fine if you understand this particular part. So I had more structure about that, but okay, it's fine. We can go into more detail in the next class. Thank you very much. Thank you for joining this session.